Hello and what's up everyone. In today's video, we are going to create an object detection system using Python. We are going to use OpenCV's deep neural network module and we are going to mix it with MobileNetSSD pre-trained Caffe model. So in order to follow along this video, you will need to download two files. I left the link down in the description. You can go ahead and check it out and download two files, the Caffe model file, and you need to download the prototext.txt file. After you have downloaded those two files, you will be able to follow along this video. So without wasting any more time, let's get right into this video. So we'll begin by importing some libraries and modules. We will need NumPy, so I'm going to say import NumPy as np, and I'm also going to import cv2 and I'll import random module as well, random. After that, we can build a list of all the classes that our model will be able to predict. So I can say something like this. So this classes list, it contains all those classes that our model will be able to predict. In other words, these are the labels of our model. Next, what I'm doing is I'm defining a list of colors and I'm setting these colors equal to a list of tuples, and each tuple has 3 values and each value ranges from 0 to 255. So we can use these values as an RGB values later on to define some colors. Actually, we are defining a random color for each individual class. We have 21 classes and we will also have 21 random color. We can now load in our model. So as I already told you, we are going to use the Caffe model and we are going to load that from a file. So I can say net equals to cv2.dnn.read net from Caffe, and this read net from Caffe, it takes 2 arguments. So the first argument is the prototext.txt file and the next argument will be the actual Caffe model file. So I have both of those files here. As I already told you, you can download both of these files from the link down in the description. So first I'll need to grab the relative path of my prototext.txt file, so I'll paste it here. Then also I need to grab the relative path of the Caffe model file, so I can copy it from here and paste it inside these double quotes. So by doing this, we have loaded in the model, the neural net. Now what we need to do is we need to load in our image on which we want to perform the object detection. So I can say img equals to cv2.imread, and this imread takes one parameter or argument, that's the path to our file, and my file is inside images /example_01.jpg. This is the image I'm going to use. You can use some other image or you can clone the Git repository to this project and you will find a folder named images. Then you can also use these images. So now that I have loaded in the image, what I need to do is I need to grab the height and width of this image. So I can say h(w) equals to img.shape, and this will give us the height and width of our image. Then what we'll need to do is we need to create a blob from our image. So we can say blob equals to cv2.dnn.blob from image. What this blob from image function will do is it will do the mean subtraction to our image and also add a scaling factor for normalization, and also what it will do is it will crop our image if needed. So it's going to take few arguments. You don't need to worry about how it works and all that stuff. Right now we are only trying to do object detection by using this function, so it's already made for us. But if you want to go in the detail, let me know down in the comment section. I can make another video on how this blob from image function works, so do let me know about that. So what this blob from image will take is the first argument that we will give it is the resized version of our original image. So I can say cv2.resize and pass in the image and give it a new size, let's say 300, 300. So this will resize our image to 300 by 300. Next, it will take few more arguments. Let me just paste them here. So the second argument is the scaling factor, and I'm defining this size as well. It's a tuple and we have a mean value as well. So you don't need to worry much about these values because right now we are just trying to get our model up and running. As I already told you, if you want the detail, do let me know down in the comment sections. So after we have created the blob, now we need to pass this blob through our neural net. The way we can do that is we need to set the input to our DNN. So we can say net dot set input and we will pass the blob. Then we can start detecting our objects. So we can say detections equals to net dot forward. So now if we print out these detections, let's see what we get. Print out detections. If I save it, run the code, let me make it bigger. You can see we got a matrix, we got an array, and we have some values inside it. Just to make you guys understand, I have created a version of this output here so that we can see it clearly. So we are getting an array, and inside that array we have one element, and that element is also an array. And inside that array we have one more element, and inside that array we also have one element, and that element is also an array. And inside that array we have lots of arrays, and these arrays are the actual detected objects that our model has predicted. So this array right here, this element, it's one detected object, and we have some information about that detected object inside this array. So this thing right here, the second value, as you see, is the class index, to which class our object belongs. So this is the predicted class index that our model has predicted. Next is the accuracy. So our model is predicting this class by this much accuracy, which is not good in this case. So, and the rest of these values, these are the scaled down coordinates of our object. So we can use these values in order to find that object on our original image. So we'll see this later on how to do this. What we can do next is we need to display on our original image what our model is predicting, and the way we can do that is we can draw the bounding boxes around the detections that our model has predicted. In order to do that, we need to loop through all those detections first that our model has found. We can say for I in np.range 0, detections 2. So by this line of code, we are looping over all those detections that our model has found. So if I come here, in order to loop through all these objects, we first need to access the 0th element of our original array. Then we need to access the 0th element of this array, and then we will be able to access all these detections. So this is what I'm doing here. So I'm looping through all those detections. Now we will grab the confidence from each of our detections. So I can say confidence equals to detections, and what I'll do is I'll say 0, 0, I, because I is going to be the object where we are right now in our for loop. So I, 2. That's because, as I told you, this thing here is our confidence or accuracy, and in order to access this, we need to first access the 0th element, then again 0th element, then we can start coming here and start accessing this value here. So that's what I'm doing here. This is just the basic Python. You should be able to make sense out of it. Then we can use this confidence in order to filter out all those detections with less confidence values. So we can say if confidence is greater than 0.2, then we want to do the following stuff. And what we want to do first is we need to grab the class ID. We want to grab the class ID of our detection. So we can say ID equals to detections 0, 0, I, 1. That's because our class ID is located here. So we need to say all this stuff in order to access it. So now that we have our ID, what we can do next is we can start building the bounding boxes around our objects. So in order to do that, we need to first grab all those coordinates that I already told you. These coordinates, these are the coordinates that we can scale up in order to draw the boxes around our objects. So what we can do is we can say box equals to. So before typing anything, let me first tell you how we can draw that bounding box. So in order to draw a bounding box, we should have the coordinates of our starting point as well as the coordinates of our ending point. So we should have the X and Y coordinates of our upper left point as well as the X and Y coordinates of our lower right point. So we can come here and say box equals to detections And what do we want inside detections? 0, 0, I. Then we want to grab all the values from the third index to the sixth index, and to do that we can say 3:7, and after that we will multiply these values by np.array, and we are going to multiply width to our x values and height to our y values. So this will give us the scaled up coordinates of our object. So now let's name them differently so we can use them individually. So I can say start x, start y, end x, and y, and set them equal to box.as type int. So now that we have done that, we are ready to draw the bounding boxes around our detections. So in order to do that, we need to draw a rectangular on our original image. So we can say cv2.rectangle, and the first argument is the image on which we want to draw this rectangle. So in our case, it's img, and we also need to give it the starting coordinates of our rectangle, the coordinates of the starting point of our rectangle, or you can say the upper left point of our rectangle. So we can say start x, start y. Then we'll need to give a tuple of our end x and our end y values. So end x, end y. Okay, next we need to define the color. In our case, as we have already defined it here, we need to access those colors. So the way we can access those colors is we can say colors and pass in the class id. So we can say, actually it's colors, so we can say int id. So this will give us the color that we can use to draw our bounding box. So now we have defined the color to our rectangle. Next we need to define the thickness. I'm going to give it the thickness of 4, let's say, and now that's it. Now if I come here and I display my image, I can say cv2.imshow, and we need to give a name to our output window because this imshow is going to produce an output window. So we'll name it output. You can name it anything, I'm naming it output, and then we'll pass in the image that, because that's what we want to display on this window which this imshow will generate. So next we need to say cv2.wait key 0. Okay, so if I save my code and run it, so we have an error. That's because I forgot it's not detections, it's actually detections.shape. Sorry about that. So now if I save the file and run the code, you can see we have successfully detected a horse inside our image, and we have also drawn a bounding box around this horse. So isn't this awesome? So now the only job left is to label this horse. So we can add a label on top of this rectangle in order to label our horse. So, but there's one problem. We'll come back to that later. Let's first see how we can add a label on top of this rectangle. So close it. So let me just, so in order to put labels on top of this rectangle, what we can do is we can say cv2.putText. Okay, and this put text, it will take few arguments. So the first one is the image, of course, on which we want to draw this text. So I can say img. Next one is the text that we want to put on this image. So we can say, we can grab the text, we can grab the class name from our classes by saying classes and give it an index of int id, because we have grabbed the id already. Now we can use it in order to grab the name of our class name, in order to get the name of our class. So next argument is the origin, and it will be the x and y coordinates from which we want to start our text. So I can say start x, let's say yes, start y minus 10, because we want to put it on top of our rectangle. So we can say start y minus 15. It will put the text on top of our rectangle. The next argument is the font face and font scale. So I'm going to give it cv2.font_hertzsey_simplex, and I'm keeping the font scale at 0.5. Then we need to give it a color. So I'm going to give it the white color. So I can say 255, 255, 255. This is how we define the RGB colors. You might be familiar with this format of colors if you are watching this video. Next argument is the thickness. So let's give it a thickness of 2. So now if we save our file and run the code, so now let's give our program a try. But before running our code, let's use a different image this time. Let's use example_09.jpg. I have this image inside this images folder. So if I save my file, run the code, you can see we have labeled our object this time. We are detecting 3 objects, this car, and a person, and each object is labeled correctly. So it's working fine, it's working perfect. But there is one problem. We are displaying these labels on top of our rectangle. But what if our object is up top here and we don't have a room to draw our label? In that case, we need to draw this label inside here, somewhere around here. So to do that, we need to add a few lines of code. So what we can do is we can say y equals to start y minus 15 if start y minus 15 is greater than 15. So if we have a room, then we are going to draw the label on top of our bounding box. But if we don't have enough room, then we can say else. What do we want? We want start y plus 15. So if we don't have enough room, then we want our label to be below our top edge of our bounding box. And now we need to replace this start y minus 15 with y. So if I save this, run my code again, we should get the same output. So if I do it, so do we have an error? So I have a typo. So I have a typo somewhere around here. So this is start y. So if I save it now, run the code, you can see we get the same output. But if we don't have enough room to print our label or draw our label on top of our bounding box, then this label will be drawn below our bounding box. So this is how it's going to work. Let me give you an example. I have an image file called car.jpg inside my images folder. So if I save it, run the code, what is the problem? It's actually car.png. So if I save it, run the code, you can see right now we don't have room to draw our label on top of our box. So it's drawing this label inside this box. So this is it. Now our code is working perfectly. Now our code is working fine. So now we need to add one final thing, that's going to be a rectangle below our label. So let me show you what I'm talking about. So I can come here and say cv2.rectangle and I'll draw it on image, and then I'm going to give it a starting coordinates. So start x comma start y minus 30, and the ending coordinates are going to be end x comma start y. So these are going to be the ending coordinates of this rectangle. Then I'll give it a color. So colors and ID and a thickness of -1 because we want to fill the entire rectangle. So if I save it and run the code, before running the code, let me just change the image. We are going to use example_09. So if I save it now and run the code, you can see we have drawn a rectangular box on top of our original bounding box, and it's acting as a background fill color for our label in order to make our label more visible. Next, what I'll also do is I'll indent this label a little bit. So in order to do that, we can say, where did it go? So we can come down here in our put text and we will say start x plus 10. It will add an indentation of 10 pixels. So if I save it and run my code again, you can see our text has been indented a little bit. Next, we need to handle this rectangle the same way we handled this put text, because if we don't have room to draw this rectangle, then we need to draw it inside our box. That thing I'll leave it up to you. Figure it out how you can do it, because you don't learn things until you try them on your own. So I'm leaving you with this exercise, and if you are not able to figure it out, do let me know down in the comment section. I'll let you know how to do that, and if you need any help, you can always ask me. In the next video, we'll see how we can apply this on a real time or on a video. So give this video a thumbs up, comment down below, like, share, subscribe. Peace out.